Hi guys! This is
Wow Facts!
Good day viewers! For today's video, we're gonna talk about 3D modeling and game programming. Sounds familiar, right?
Yes!
3D modeling refers to the process of creating a three-dimensional representation or digital model of an object or scene using specialized software. This technique involves building of virtual object with various shapes, textures, and materials, giving it a realistic appearance. But how is 3D modeling became part of our daily lives? Who discovered it?
The trend of 3D modeling can be traced back to the middle of the 20th century when the concept of computer graphics started to emerge. Particularly, it happened in 1963 when Ivan Sutherland, a computer scientist from the USA, or the father of computer graphics, began to explore his strange curiosity. He was born in Nebraska, and his father was working as a designer in a Kingsley dam. He went to see many of his father's dams. He knew a lot about how they work and what they were. His mother, who is a teacher, had inherited a registered black collection and would ask him to make something from the designs. Then she would check if Ivan had done it correctly. And from that, he learned about how to read blueprints and build bridges accurately at a young age. In 1960s, everybody works on a computer, and Ivan wondered that maybe artists can possibly benefit from it. So, he wrote a program called Sketchpad, or the first 3D modeling software. The evolution of computer-generated imagery began with Sutherland's idea to create software, allowing a computer to read drawings that were depicted on the screen with a light pen. Sketchpad could produce many similar drawings by using only one main drawing. Moreover, when the user corrected the main drawing, all derived drawings changed accordingly. He also invented the SWORD Demopause, a unique helmet that could generate a field of vision for the user. Later on, further advancements has been made about 3D modeling, including the different ways to represent models.
There are three popular ways to represent models. First, polygonal modeling. The process of polygonal modeling involves creating vertices, defining edges or line connecting vertices, and filling in the enclosed area with polygons. Polygonal modeling is widely used in various applications, including video game design, animation, virtual reality, and architectural visualization. Second, curve modeling. In curve modeling, the artist typically starts by creating a curve using various tools provided by the modeling software. Curve modeling is particularly useful for creating organic and natural shapes, such as characters, animals, vehicles, complex architectural form with smooth curves and surfaces. Lastly, digital sculpting. It involves manipulating digital clay-like materials virtually to sculpt shapes and forms. Traditional sculpting, which uses physical tools like clay, stone, or wood. Digital sculpting allows artists to work on their creations using digital brushes, push and pull tools, and other techniques in a digital computer or other digital device. Here's some popular 3D modeling software. First, Autodesk Maya, a widely used film, television, and video game industries for 3D animation and rendering. Second, ZBrush, often used in film, game, and jewelry industries. And the last one is Cinema 4D for modeling, animation, and rendering, widely used in motion graphics and visual effect industries. These are just few examples, and there are many 3D modeling software available, each with its own unique features and specializations.
Now, there are many industries and sectors where 3D modeling is applied. The first one is animation and film industry, like Pixar, DreamWorks Animation, and Disney. The second one is architecture and construction. Tools like AutoCAD, Revit, and SketchUp are popular in this field. The next one is product design and manufacturing. The fourth is engineering and industrial design. Next is gaming and virtual reality. The sixth is advertising and marketing, allowing photorealistic products, renderings, or lifelike digital characters. The last one is medical and healthcare, helping doctors, surgeons, and researchers visualize patients' specific information. Challenge in 3D modeling. The creation of 3D content has been quite popular recently. However, despite its wide adoption, creating 3D contents continues to be a major challenge for many brands. First is cost. Creating 3D content typically requires a team of skilled artists, animators, and technicians, which can also drive up costs. Long duration of a project. Creating even a simple 3D model can take hours or even days. Next is team allocation. While there are many talented 3D artists and animators available, finding individuals with specific skills and experience needed for a particular project can be difficult.
Now let's move on to the pros and cons of 3D modeling. First, the visual. 3D models can be eye-catching. Humans are good at processing visual information. Second, intuitive. Humans live in a 3D world. 3D representations are compatible with the human experience. And lastly, immersive. Viewers can interact and engage with 3D models. Now are the cons of 3D modeling. First, yes, it is difficult. Exactly. Software packages require considerable expertise. Second, data intensive. 3D models can be huge. 3D renders can require supercomputers to process. Third, time intensive. Added realism requires added manpower. Modeling details can be extremely time-extensive process. There are many ups and downs in developing 3D modeling, but on the other side, many improvements have been made over the years. That is why it is still considered as an emerging technology because modern 3D modeling has the potential to create fully interactable photorealistic models, which helps users experience a virtual reality that is different from our reality.
Hey bro! We're done taking our video! It's your turn! What is that? Are you telling your ex?
No! I am writing a program for my game, bro, okay? Dang! Now, what really is game programming? Game programming is also known as game development or developing video games. It refers to the code that brings a video or computer games to life. As technology has evolved, so has programming. Early on video games history, programmers were often responsible for most aspects of game development, including game design. So how game programming became a trend?
These days, video games are everywhere, but they were actually made in science labs. In fact, the earliest US video game patent on record was in 1948, and at the time it was referred to as a category 2 amusement device. Some of the earliest video games include the Emerald Computer, OXO, Tennis for Two, and my personal favorite, the Space War. But none of these early video games were ever sold to the public because they were either too huge or too expensive to get out of the lab. This all changed when a man named Ralph Baer looked at his television screen and wondered how else it might be used. In 1972, Baer's idea to get video games out of the science lab and into the living room led to the release of a game console called Odyssey. Odyssey allowed you to play a game on your TV throughout the late 1970s to the early 1980s. The golden age of arcade video games was the first period of rapid growth, creative and technological development, and cultural influence made possible by new computing technology with greater power and lower cost. Arcade video games revolutionized the entertainment industry. By the mid-90s, the golden age of arcade games was coming to an end, and the home game console was gaining in popularity. While arcade games continued to decline in sales over the years, the popularity of video games was merely beginning. Later on, many games families have evolved, from arcade gaming like Space War to mobile gaming, and now we have the so-called esports.
Welcome to Mobile Legends!
Application. First, entertainment industry. Second, education training. Third, simulation and virtual reality. Do you want to become a game programmer? Here's the tools. Unity, GameMaker, Contracto, Unreal Engine. The challenges of game programming. First is cost for software and skilled programmers. Second, long duration of a project. The hardest part of making a game has always been the engineering. In times past, game engineering was mainly about low-level automation, writing code that would not quickly in the target computer, leveraging clever little tricks whenever possible. But in the past 10 years, game have beyond complexity. Here's the pros and cons of game programming. First, creativity. Game programming allows for creative expression and all the opportunity to bring imaginative ideas to life. Second, challenge. Game programming involves complex problem solving and requires constant learning and adapting to new technologies and techniques. Third, high demand. This leads you to job stability and potentially high paying position. Cons of game programming. First, long hours. This can lead to burnout and work-life balance challenges. Second, stressful deadlines. Third, competitive environment. The gaming industry is highly competitive and securing a job can be challenging, requiring constant skills, developing and building a strong portfolio. And fourth, frequent changes. The technology and trends in gaming evolve rapidly, requiring game programmers to continuously learn new programming languages, frameworks, and tools. And the last but not the least, limited creative control. Game programming often involves working on specific tasks in a larger project, limiting individual creative control over the direction of design of the game.
So these are the 8 steps of game development stages. First, evaluation. The first step to the game development is the evaluation of your idea and your requirements. The second one is pre-production. This is the planning stage and a clearance stage. Game type, platforms, target audience, gameplay, game mechanics, characters, plot, and monetization strategy. The third one is production. Now is the time for the most dynamic, long, and difficult stage. This will also be the most lengthy stage. Graphic and designing, programming, and sound engineering. The next one is testing. Quality assurance in testing is the stage that will check each aspect of the game to ensure. The fifth stage is pre-launch. This is the stage in which you will let the people know that you are going to launch an amazing game. The sixth one is launch. Until the day of launch, the development team will keep finding the bugs. The designers will improve the design and texture of all the assets and characters, and the developers will improve the smoothness of the game. The seventh stage is post-production. This stage is the maintenance stage. The last stage is updates and upgrades. Your game will need a new element to keep it interesting for the existing players.
So why game programming is an emerging technology? First, increasing demand. The gaming industry has grown rapidly in recent years and it continues to expand. As a result, there is a higher demand for skilled game programmers who can develop innovative and engaging games. Second, the advancement in technology. The continuous advancements in technology such as powerful hardware, graphics processing units or GPUs, virtual reality or VR, and augmented reality or AR devices have enabled more complex and immersive gaming experiences. Game programmers are needed to leverage these technological advancements and create innovative gameplay mechanics. Lastly, the accessibility of game development tools. With the availability of easy-to-use and affordable game development tools and software, more individuals and smaller game development studios can enter the industry. This accessibility has given rise to a host of indie games and mobile games which require game programmers to develop and maintain.
And that's all for today. My name is Trixie MAYLID.
I'm REBUSA.
I'm Claire Nakila, and
You are watching Wow Facts!